Hello. In this video we're going to learn how to write if-else statement in the assembly, and for this I have a C code with if and else statement, and I'll just translate it and explaining the control flow in assembly, because in assembly we don't really have if or else, and the way is you need to write the code in such a way that it works as if there was an if and else statement. Basically, if and else is a lie. There's a control flow going on. So in this video we'll also learn what's going behind the compiler when you write if and else, how the computer interprets that set if and else. How does the computer make your if and else? Okay, so let's begin. And first of all, of course, I need to write the name of the function, entry point, and the two golden rule, push EBP and move ESP to the EBP. Golden rule which you would to write always. So next, as we can see, we have an integer declaration, which is basically the return value. And as we know, return value is stored in register EAX. But we already have EAX, so we don't need to declare EAX. In assembly you don't declare stuff, although you could allocate some memory on the stack or just in memory or wherever, however you want, but in this case we don't need to declare anything. So what does the let's first access our the passed argument a. So how do we do that? We write move all $8 EBP to EDX, and I explained in my previous video how does this work, so if you don't know you can check my previous video. And now what we do, we need to see how does our EDX, or aka our A or argument variable, to 0. And how do we do that? Well, there is a instruction compare, and it takes two operands which have size, and in this case I'm going to use EDX, so I write L, and I'm comparing 0 with EDX. Now I'm going to talk about this compare statement or instruction. So what does it do? Basically, like, let's say you have 5 in EDX. If you subtract 0 from EDX, which means 5 minus 0, and as we know, source is always on the left and destination always on the right. So what compare does, it as if does this kind of operation. So if I had here 3, assembly would execute something like this. And now why does it need it? By subtracting, it stores some values into the flags. So for example, if EDX was 5 and I compared it with 5, 5 minus 5 is 0, right? So there is a special flag called 0 flag, which would turn on. Basically it's a value, which means that 0 flag would become equal to 1. So now the processor knows that the last operation yielded result 0. But the compare instruction does not alter EDX. It as if subtracts and populates flags only. It does not change EDX nor its source. So it is basically a subtraction without storing result of subtraction, but instead we populate flags. And also you can't do every kind of comparison operation with just 0 flags. There are several other flags. For example, there is sign flag, and it will become 1 if we had, for example, 6 here and EDX was 5, which means that 5 minus 6 is minus 1, and this would activate sign flag. And there's also overflow flags, and with help of these flags, the processor basically knows everything about your previous instruction. So even if you did not put compare and you just subtracted 0 from EDX, flags would have been updated. But in this case we don't want to change our A because we need it. Okay, so that's pretty much explains compare statement. But now, why did we need all that? So the thing is, we don't have if or else in assembly. So we use conditional jumps, which means the following. Every instruction, like this or this or this, and even here it's padding, every instruction has its own address. Instructions are stored somewhere, right? And of course they have their address. So by writing something like jmp and, for example, al1, if we have address al1 here, this would alter the control and go back to here, which means that this line would execute again, this would execute again, then this line would bring us back to this line, and this line, and this line, and back to this line. So it is infinite loop basically. So we don't need infinite loop now. We need to write our if-else statement. So what do we do now is next. So it is a little bit counterintuitive at first, but instead of writing if EDX is less than 0, we write if it is greater or equal to 0, which means that it is positive. And let's jump it to positive. Let's make jump to positive. We don't have positive here, it will be somewhere like here, for example. Let me write it first. It doesn't really matter which you write first, but it might be more better to understand like this. So we have positive here, and what we do in case our argument had a positive number, we need to store 0 into the EAX, because according to this if statement we come to else only if A is greater or equal to 0. So we can do also move L 0 to EAX, which means setting the return value to 0, or we could do XOR L, exclusive OR. But exclusive ORing is with itself. EAX with itself, according to Boolean algebra, if you know Boolean algebra, XORing anything with itself will always yield 0. But even if you don't know Boolean algebra, but just by memorizing that this will yield 0 in EAX, that's pretty much enough. But that's in this case to avoid Boolean algebra. Let's just move L 0 to EAX. So we wrote else statement now, because if else is false, we come to no. If is true, if is false, we come to else and hence store 0 into EAX. Now we need if statement. So in case this was true, which means this is false, so our A is less than 0, we don't do conditional jump, so we don't come here. And the next line should be something like move L1 into EAX. So this stores 1, basically this executes this line, stores 1 into our return value. But now the tricky thing. The next line of assembly code is move L $0 into EAX. Hence we need to skip over this, so we need jump statement again. But in this case we don't need conditional jump, we just need to jump like in any case. So we don't set this EAX to 0 because A is positive. And let here be done, and hence pretty much that's it. So we pop L EBP, move EBP to ESP, and return. And that's pretty much explains how to write if and else statement. The control flow, let's just to summarizing, even if you don't want to like too much logic, just you write the negative of else if statement, and this will alter the control flow and executing else statement. And if this was true, then this line will execute, and this line is this line. So like this is the only way you can do if and else statement in assembly. You need to alter the control flow. So if this was a little vague how all this works, I think you should try some stuff yourself and see how it works. And also, if you're familiar with go-to statements in any language, I think you should have understood this, because it's basically the same. So it's basically the same, kind of. And also I want to talk about just one thing before we finish. In case you want to do some other instruction, like in this case is jumps if greater. But if you would want to jump in some different condition, you could write jump if sign. Means that it should jump if the last operation yielded negative value. Also you could write jump if just greater, not equal. Jump if just greater, if EDX was greater than its source. Or also you could write jump L, which means jump if less, or jump if less or equal. So it's very intuitive. L means less, E means equal, and G is greater, G is greater. And for unsigned numbers we have above or equal, or below or equal. So that's pretty much all the jump instructions. Also there is not sign, which means not negative, because S is just sign. And that's pretty much it. So we have jump greater here. So in this video we learned what does compare do, and about flags, but you don't really need to know like every flag or the boolean operations behind flags according to which jump is executed, but intuitively just by comparing you can write a code. But if you want to research about flags, of course you can do googling and learn. And we learned about jump instructions, which is a control flow which alters which line executes. So I hope this was informative. Thanks for watching.